Okay, as promised, we have one piece, or maybe two pieces of new information, and then we will do our Christmas exchange and talk about reviewing a little bit.
Organic peanut butter.
Sometimes,
The protein Starbucks.
maybe later today or over the weekend or something, I need you to fill out your student feedback. You know, you have to do that for all your teachers. You've probably already done it for some, I don't know.
We just write it up there.
But I just wrote it up there to remind me. No, you don't write it up there. So on my website, down at the bottom, someplace on there, there's a folder and it says student feedback. When you open that up, you'll see semester 1, 14-15 or something like that. Anyway, it's identified as this semester. So if you'd fill that out, that would be absolutely magnificent. Thank you. It is a requirement that we all turn those in, so I need your help, obviously, to do that. Okay, so today our new pieces of information. And yes, what were our new pieces of information yesterday? Tangent and cosecant. Okay? Today our new pieces of information are secant and cosecant. Now, I'm just going to jump in because we have so much other stuff to do today. I'm just going to jump in and look at maybe what might be kind of a wild problem. How about y equals 3 cosecant to x minus pi over 3. We'll just stop at that. That's enough. Now, believe it or not, as hard as this looks, it's really pretty easy. All you have to do is pretend for a minute that this doesn't say cosecant. Pretend it says sine. Now, why would I do sine, do you think? Because it's the reciprocal of the cosecant. Okay, so now that's kind of old news. That we already know how to sketch if this is a sine. What does this 3 tell me? My amplitude's 3. Right? What does this 2 mean? What does that 2 do? That changes the period. So the period of a sine is supposed to be what? 2 pi. But we've divided by 2, so our period is now pi. What does this tell me? It moves right pi over 3. So I have a sine curve, and I'm going to go ahead and do it in a dashed line, because remember, I'm just pretending that says sine. That's what it would look like if it said sine, right? Now, what's this label? Let's get these labels done. What's the end label? Now, remember, you told me the period was pi.
1 1/3.
1 1/3, or I might say 4/3. But it is definitely 1 1/3. I hope you all followed that logic. If it starts at a third and it travels 1, then it's going to end up at 1 1/3, right? Now, what's halfway between? This is one of the tricky ones. Remember, halfway would be the midpoint, right? And the midpoint is the average. And how do you average? You add and divide by 2. So what is 1/3 plus 4/3? 5/3. And what is half of 5/3? 5/6. So my midpoint is 5/6. One more time. Madeline, one more time. How did I do that? I added 1/3 and 4/3 and multiplied by half. I averaged. Now I need to do the same thing. Only now I'm adding 1/3 plus 5/6. What is 1/3 plus 5/6? 7/6. And half of that would be 7/12. To find the midpoint, you add and divide by 2, you average, you add and divide by 2. All right, so I do the same thing here. I have to add 5 sixths and 4 thirds. So that would be 5 sixths and 8 sixths. That's 13 sixths, and then I have to cut it in half. So that would be 13 twelfths. Now that would be the answer if the question had been assigned, right? Okay, but it wasn't. So how do I move from here to a cosecant? It's so simple. You're exactly right, I'm gonna flip it, but there's a piece in there I have to, no, I'm flipping it this way, but there's a piece in there I have to keep in mind, and that is, at this point right here, and here, and here, the value of the sign is 0, correct?
Yeah.
So when I take the reciprocal of 0, what happens? It's undefined. And undefines are graphed as asymptotes. So every time we cross the axis, the x-axis, we put in an asymptote. Because at these points, the reciprocal will be undefined. So we have to have an asymptote there. Then we take this hill and we flip it. So when I flip this hill, it becomes like a little parabola. And then I take this valley and I flip it and it becomes another little parabola. So the purple thing is the answer. It's okay for you to leave this in here, but I'm going to take it out so there's no confusion. That is a picture of this cosecant curve. So, really nothing new to graphing a cosecant except putting in the asymptotes and flipping the curves. What's the amplitude of this picture? Actually, it doesn't have amplitude. Because, now the 3 is important. There's no question about it, the 3 is important. But why is there no amplitude? Because there's no top and bottom. Remember? You gotta have a top and bottom. There's no top and bottom. What's the period? Pi. What's our phase shift? Pi over 3. And what's our vertical shift? None. There's no vertical shift. Right? Didn't put anything on the end of it. Didn't pick it up and move it anywhere. Okay, I need to erase. You got all that if you want it? All right, let's do a secant now. How do you think I'm going to approach a secant problem?
Same way.
The same way, only I won't start with a sign, I'll start with a cosine. So let's throw a negative out there. Let's see, I'm doing secant. I'm gonna really trick you here. We haven't talked about this. Does anybody see anything different about this equation? Now, in the beginning, we're going to think of this as a cosine. So pretend it's a cosine. Do you see anything different about the way that equation is written? Well, we've talked about that before. What does that do for me? That'll be, I'll draw it upside down. So I remember that a positive cosine starts at the top, ends at the top. So a negative cosine is going to start at the bottom, end at the bottom. So this is the shape I'm going to be drawing because of the negative. Now there's something else in that equation that's different. Okay, this guy is inside the parentheses. If you look at all of our other examples, he's been outside. And in order to sketch him, he has to be outside. So the first thing I'm going to do is pull that 1/2 out. I'm gonna factor that out. Now, what do you think is going to go here? And I am just asking you to open up your brain and think for a minute. What would go here so that when I multiply them, I get pi over 12?
Pi 24.
Pi 24, somebody said. Let's look at that. Is that right?
Steven.
If you distribute this back, do you get pi over 12?
Yeah.
You do?
6.
What's 1/2 times 1/24?
That was
Wouldn't that
wrong,
be
I'm sorry.
1/48? That's not right. What do I need to put here? I need to put a 6 there. Because what happens when I multiply a 1/4 times a 1/6? I get 1/12. Now it's ready to graph. Now we can graph it. Okay, so let's see. Now we're going to put you to 2 this time for the cosine curve. Where do I start? Where's my phase shift? What's my phase shift? Negative pi over 6. Good. So I'm going to have a negative cosine curve. It starts at the bottom of the hill, or bottom of the valley. It ends at the bottom of the valley. So here's my negative cosine curve. What's its period? Four pi. Because the period's supposed to be 2 pi, if we divide it by 1/2, so that's 4 pi. So what's this label going to be? Watch it. Remember, you started at negative 1/6. 3 and 5/6, which I would prefer to write as 23/6, but that is 3 and 5/6. 3 and 5/6, because you started at negative 1/6 and went 4. Good. What's in the middle of negative 1 and 23? Well, let's add them and divide by 2. What's negative 1 and 23? 22. And half of that is 11. What's negative 1 and 11? 10, and half of that is 11 and 23 is, and half of that is, perfect. That is it for the cosine. Now, how do I get from there to the original problem, which was a secant? Where do the asymptotes go? Wherever we cross the axis, that's right. That's where the asymptotes go. Now, this one is easy, right? Remember, you flip them, create the parabolas. This is a little bit tricky. You might want to imagine the rest of that. Can you see that that would look like this? And this one likewise, if you flipped it, it would look like this. Because the other half is over here, it would look like that. Period's 4 pi. What's our phase shift? Negative 1/6. No vertical shift again. And what's our amplitude? None. Okay. Real quick review of, we'll do a tangent or cotangent just to make sure everybody's still on board. Let's graph a tangent. Let's graph this real quick. Okay, we ready? Okay, what's a tangent look like? A squiggly line, right? Does it squiggle through the origin, or does it have an asymptote at the origin?
Squiggle through the origin.
Squiggles through the origin. This is a positive tangent curve. It squiggles through the origin, looks just like that. What's the period? period. The period's supposed to be pi, but I stuck a number in there. So what's my period? 1/4 pi. That means that this whole distance is 1/4 pi. Asymptote to asymptote is 1/4 pi. What then would these labels have to be for these asymptotes?
1/8 to -1/8.
Negative 1/8 and 1/8. And that's it. We love our tangents. Okay? All right, tonight's homework is gonna be your mini review. So if you find that, we'll do a little review while we are sharing our Christmas gifts. So this is your family review. It's not, this is not your packet, this is your exam review.
No idea what that is. Thank you. Thank you for sharing these. Nice gifts.
Yeah.
This it?